next we'll start trying to solve the problems. Okay. So first question, we have a long strip footing of width 2 meter carries a load of 400 kilonewton per meter. Okay, you should not hear it is kilonewton per meter. Calculate the maximum stress at a depth of 5 meter below the center line of the line of footing. So the given data, what are the given data? So we have a 400 kilonewton per meter acting on a level surface 2 meter. Okay, it's marked. So we have angle alpha, right? Alpha is not given. Okay, at the depth of 5 meter at point P. Okay, so we have the direct equation sigma z is equal to q by pi multiplied by alpha plus sine alpha. Right, it is acting directly below the load. Right, so we take here tan alpha is equal to 1 by 5, that is zero point 0.2. Okay, tan alpha by 2 is equal to 1 by 5 equal to zero point 0.2. So alpha by 2 is equal to tan inverse of zero point 0.2. Okay, which is 11.31 degree. So you have to convert it into zero point 0.1 into radians. You can convert directly in the calculator by switching the mode to radians. Okay, you get the answer, and then alpha is equal to 0.197 radians into 2. That is, we take this 2 to here, and you get it 0.395 radians, which is again converted to degree. Okay, we want alpha in degree, right? So we solve it to the equation as sigma z is equal to q by pi multiplied by alpha plus sine alpha. So sine alpha is sine 0.395. It is, we should take it in radians, then you get it as 0.385. Okay, so taking q is equal to 400 divided by 2. Why is it 400 divided by 2? Because we want the answer, we want the load in kilonewton per meter square, but we have the given load is 400 kilonewton per meter. So to convert it to meter square, we divide it by 2, then we get it as 200 by kilonewton per meter square. And then you can directly apply sigma z is equal to 200 divided by pi multiplied by 0.395. Okay, get it 0.395 plus sine alpha. What is sine alpha? 0.385. Okay, so you get the answer as 49.6 kilonewton per meter square. After seeing this video, you try to solve this by yourself, so you'll have much more clarity. Okay, don't just see the video and attend the exam. Okay. So next question. Next question is a very simple question. Okay, vertical stress at a point P. Okay, you can see the notes and we can directly apply the equation for a line load. Every values are given directly here. Okay, in the same way, you have a problem for a circular area. So we have you have all the values directly given here. You can just solve it by yourself. You can just check it. Okay, it's very simple question. So if your university is asking, it might ask for 3 mark, not more than that. I'll ask for these kind of simple questions. Okay, next question. A ring footing of external diameter 8 meter and internal diameter 4 meter rests at a depth of 2 meter below the ground surface. It carries a load intensity of 150 kilonewton per meter square. Find the vertical stress at a depth of 2 meter and 4 meter along the axis of footing below the footing base. So we have external dia and internal diameter is given. Right. Okay. After that, what is given? Capital R is given small r. Okay, radial distance is given here. Right. First, we need to find for a 2 meter distance. Find the vertical stress at a depth of 2 meter. Then what is given? And 4 meter along the axis of footing. Again 2 meter plus 2. So it will be total 4 meter. Right. For a circular area, so we take for point P, for P sigma z is equal to Q into 1 minus 1 plus R by Z whole square, whole to the power 3 by 2. It's a direct equation. So what do you have to find? Stress at first at 2 meter. Right. So you take vertical stress is equal to external stress at external minus stress at internal. So first stress at external. What is the load given here? 150 kilonewton per meter square multiplied by 1 minus 1 by 1 plus R by Z. What is R given here? 4. 4 divided by 2 whole square to the power 3 by 2. So you get answer here as 136.58 kilonewton per meter square. And then you take internal vertical stress 150 multiplied by 1 minus 1 by 1 plus 2 by small r 2. Right. 2 divided by 2 whole square whole to the power 3 by 2. Okay, you get answer as 96 kilonewton per meter square. Then you multiply this external minus internal vertical stress. So you get the answer 39.616 kilonewton per meter square. Then next, what was given the question? And the vertical stress at a depth of 4 meter along the axis. Right, 4 meters given. Same way you multiply 150 multiplied by 1 minus 1 by 1 plus 4 by 4 whole square whole to the power 3 by 2. You get the answer as 96.967 kilonewton per meter square. And then you take the internal. Same way 150 multiplied by 1 minus 1 by 1 plus 2 by 4 whole square. Okay, to the power 3 by 2. You get the answer. Then you minus, deduct from 96.96 minus 42.66 kilometer square. You get the answer for both of them. Okay. Okay, similarly, try to do this problem, and then we go to a rectangular L-shaped. Okay, an L-shaped building in plan exerts a pressure of 75 kilonewton per meter square. Okay, on the soil. Determine the vertical stress increment at a depth of 5 meter below the interior corner P. Then you have the diagram here. Okay, here interior corner P. Okay, from total is 25 meter. Here we have 30 meter. So we split this into different rectangles. Okay, for example, A1, A2, A3. So you have 10 meter here, 10 meter, 15 meter, 10 meter, 20 meter, 50 meter. Okay, A1, A2, A3. So vertical stress is equal to Q into IN1 plus IN2 plus IN3. So for area A, okay, A1, sorry, for area A1, you take M is equal to B by 2. We have seen the equation, right? M is equal to B by 2 and N is equal to L by 2. So, M is equal to N. Okay, breadth and length is same here. It is 10 meter here and 10 meter here. So, what happens? 10 divided by, sorry, B by Z. My bad. It is B by Z equation. N is equal to L by Z. Okay. M is equal to N. So, what is asked here? Determine the vertical stress increment at a depth of 5 meter. Right. Z is given. So, 10 by 5. So, M is equal to N as B breadth and length is same. So, 10 by 5, you get answers 2. Okay. So, M and N both are 2. So, we take the Newmark's coefficient chart. Here M and N is 2. So, corresponding M 2 corresponding to N 2. You get it as 0.2325. Right. IN is given here. That is 0.2325 on the Newmark's coefficient chart. Okay. Then for area A2, what is area A2 here? 15 meter and 10 meter, right? So M is equal to what? B by Z. What is B by Z? Breadth is 15 meter. Okay. So 15 by 5, that is 3, and N 10 divided by 5, that is 2. So M is 3, N is 2. You look back to this coefficient chart. M is equal to 3, corresponding N. And what do you get for N here? 2. 0.2378. Okay, that is IN2. IN2 value is noted down. And then you go back to area number 3. What do you have? M length, breadth we have as 20 meter. Okay, length as 15. So 20 divided by Z, that is 5, and then 15 divided by 5, then you get 3. So 20 divided by 5 is 4, right? N is 15 divided by 3. So you have M and N. So corresponding 4 and 3. Okay, what do you get? So here if you see, M doesn't have 4th value, right? But we have N value. So what we do right now? We interpolate these values. Okay, I hope you have learned interpolation in maths. Okay, there's something looking like this, right? We check on the values what we have here. Okay, yeah. So you have to find value for 4. Okay, 3 and 5. Okay, 3 and 5 is given here. 3 we have 0.2439. Okay, for 5 we have value as 0.2461. Okay, 2461. Okay, and then you need to find 4. How do you find? X divided by 4 minus 3 is equal to 0.2461 minus 0.2439 divided by 5 minus 3. Okay, you get X as 1.1 into 10 power minus 3. For M, at M is equal to 4, IN is given by 0.2439 plus 1.1 into 10 power minus 3. Okay, so you get a value of 0.245. Okay, you have to learn this interpolation if you are not aware about this when you solve this problem. Okay, so you got 0.245, right? IN3 is 0.245. So you got IN1, IN2 and IN3. That is sigma Z is equal to 75 kilonewton per meter square. Q is given, right? So you add all this 0.2325 plus 0.2378 plus 0.245. You get 53.65 kilonewton per meter square. Okay, there are some other problems, very simple ones. So you try to solve those also. Okay, that's it.